Okay, so I'm going to try to finish off the notes for population proportion and the confidence interval. And this works pretty well to write on my iPad screen. It's not going to be super neat, but I think it'll get the point across. So we'd come to the conclusion in class that p hat, the sample proportion, is normally distributed, and the mean is p, and the standard deviation is square root of p times q over n. Okay, now given that we have a confidence interval for p using the z distribution, and that is p hat plus or minus the appropriate z value times that standard deviation. And specifically, the p and q that we put in there are p hat and q hat. Okay, where q hat is 1 minus p hat. So we have a simple example. We're just going to plug stuff into that formula to start off with. We want a 95% confidence interval. We have sample size 50, and p hat is 0.75. So our confidence interval will be 0.75 plus or minus the z value, which for a 95% confidence interval, that's 1.96, times the standard deviation. So p hat is 0.75. That means q hat is 0.25. And then that's all over n, which is 50. Okay, calculating that, we get our lower bound of 0.63 and an upper bound of 0.87. All right, you can pause anytime if you want to go back and plug it in your calculator and do it yourself. I'm going to keep going. Let's look at this next example. We have a poll of 1,200 voters. Ask what most significant issue was in the upcoming election. 780 answered the economy. We are interested in the population proportions of voters who feel the economy is the most important. And we want a 90% confidence interval. Okay, so first thing, we wanted to find the random variable x. That is the number of voters that answered in the way that we are we're interested in looking at. So it's the number of voters who said economy. And x is actually binomial, and it's got n of 1,200, the total sample size, and the p, probability of success, or the probability of answering economy, is going to be equal to the number that said economy over the total. Okay, and we can calculate that, and that's 0.65. So that's the p that goes into and defines that binomial distribution. Okay, all right. We can use that to come up with a mean and standard deviation for that value, that random variable x. Okay, the mean is we get by taking n times p. Well, n times p is, we're just kind of undoing what we did right here, right? So that is going to get us back to 780. And the standard deviation, we take the square root of n times, oops, that's not n, let's go back, n, which is 1,200, times p, 0.75 times 0.25, which is q. And that gives us a standard deviation of 13.32. Okay, Now we're going to start talking about p hat, the actual sample proportion, so we can get the confidence interval that we're looking for. So we want to define what that is. P hat is the proportion of the sample that said economy. Okay. All right, let's go to the next page. All right, so p hat is going to be that 780 over 1200. So I don't have a lot of room here. So 780 over 1200, which we already calculated that. That's 0.65. And the mean for p hat is just going to be itself. Oops, let's get rid of that. Is itself 0.65. And the standard deviation we are going to get by taking the square root of 0.65 times 0.35 over n, which is 1200. Okay, so we're just taking p hat times q hat, dividing by n, taking the square root, and that gives us a standard deviation of 0.0138. So now going back to the result I started off with, turns out p hat is normally distributed with mean of just p, 0.65. And standard deviation of what we just found, 0.0138. Now we're ready to construct that 90% confidence interval. And we take the p hat value, 0.65, take plus or minus. We want the z value that goes with the 90% confidence interval, all right, which is 1.645. And then times the standard deviation, so times 0.0138. So we end up with the interval from 0.627 up to 0.672. All right, so we can say that we are 90% confident that the true proportion of voters who would choose economy as the most important topic is in between 0.627 and 672, or 62.7% and 67.2%. Now we want to ask the question, what would happen to the confidence interval if the level of confidence were 95? All right, so we've kind of talked about this a lot. When we increase the confidence level, we have to give something away, and what we give away is precision. So that means that the confidence interval would become wider. It would widen. All right, let's look at the next example. Quality manager of a Fortune cookie company believes that a larger than acceptable proportion of paper fortunes being used are blank. Suppose she takes a sample of 320 fortune cookies from a production line and 45 of the paper fortunes are blank. We'll start off by defining the random variable p hat in words. Okay, well, it's a sample proportion. Okay, it's going to be the number that are blank, 45, over the total number sampled. Okay, so in this case, our x is that 45. Okay, remember we get this by taking that binomial random variable x and putting it over the sample size n. So we're skipping over defining x and just going straight for p hat, the sample proportion. And then we can actually calculate that. P hat, 45 over 320 is 0.14 if we round to 2 decimal places. Okay, that's also the mean that we will use for p hat, and the standard deviation, we take that 0.14, multiply it by 1 minus 0.14, so 0.86, divide by sample size of 320, and that gives us standard deviation of 0.02. Okay, p hat is normally distributed, mean 0.14, standard deviation 0.02. All right, so next we'll construct the confidence interval, and we take that 0.14, the p hat, plus or minus, we want the right z value. 95% confidence interval means we're going to use 1.96. Multiply by the standard deviation, 0.02, and we get a confidence interval that goes from 0.10 to 0.18. Okay, so hopefully you're noticing that all of our confidence intervals for proportions, right, they're all going to be decimals, right, because a proportion has to be somewhere between 0 and 1. So if you get something that's less than 0 over 1, we want to look at that and see if there's something that's gone wrong. All right, let's look at margin of error. Margin of error, all right, that's just this piece right here, that multiplying those two things together, you get margin of error equal to 0.0392. Okay, now we want to say what this means in a complete sentence. I'm not sure I'm going to totally be able to fit this in here, but we are 95% confident that the true population proportion is, or proportion of fortune cookies that have blank fortune is in the interval 0.10 to 0.18. I would write more out there if I had the space and could do it with this pen on the iPad, but I think we get the idea. We've talked about that a lot. All right, next question. Suppose we want to lower the sampling error, all right, which is another term for margin of error, which you can see used quite a bit. What is, how can we accomplish that? Okay, so we want a smaller value here, all right? We want to add and subtract something that's smaller. So the ways that we can do that are either to increase n, increase the sample size, and the other way is to, hopefully you already are saying it out loud or writing it down on your notes, decrease the confidence level. Okay, so that finishes off the notes. I hope that is helpful in working out the assignments. Feel free to give me an email anytime you have a question, and I'll get back to you as soon as I can. All right, have a great rest of your week, and have a great weekend. I'll see you next week.